Hi, my name is Burns, and here's my partner John. So in this video, we're going to be using two angle methods to prove that triangles are congruent. Using the hypotenuse leg right angle method to prove triangles are congruent. The hypotenuse leg right angle theorem, also known as HLR but often called the HL theorem, states that if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. The following figure shows you an example. You can call this theorem HLR instead of HL because it's three letters emphasized, so before you can use it in a proof, you need to have three things in the statement column: congruent hypotenuses, congruent legs, and right angles. Note that when you use HLR, listing the pair of right triangles in the proof statement is sufficient for that part of the theorem. You don't need to state that the two right triangles are congruent. Are you ready to prove triangles congruent with the HLR method? So our given is angle ABC is an isosceles with base segment AC. Segment BD is an altitude. Our proof is segment BD is a median. So here's our triangle with A at the left part of the triangle, B as the peak, C is the right part of the triangle, and D is the midpoint of A and C. Here's the proof. Statement 1. Angle ABC is isosceles with base segment AC. Reason, it's given. Statement 2. Segment AB is congruent to segment CB. Reason, definition of isosceles triangle. Statement 3. Segment BD is congruent to segment BD. Reason for statement 3, reflexive property. Segment BD is an altitude. This is for statement 4. Reason, it's given. Statement 5. Segment BD is perpendicular to segment AC. And the perpendicular sign, as we can see, it's that from top to bottom, it resembles BD, and from left to right, it resembles AC. Reason for statement 5, definition of altitude. Statement 6. Angle ADB is a right angle, and angle CDB is a right angle. Reason, definition of perpendicular. Statement 7. Angle ABD is congruent to angle CBD. Reason, HLR, using lines 2, 3, and 6. Statement 8. Segment AD is congruent to segment CD. Reason, CPCTC. Statement 9. D is the midpoint of segment AC. Reason, definition of midpoint, as D is in between A and C. And lastly, statement 10, what we need to prove is that segment BD is a median of angle ABC. Reason for statement 10, definition of median, as BD is surrounding A and C. The next angle method is to be presented by John. So since John doesn't do animation, his part will exclude animation, unlike mine. So it's until the end, there won't be animation until the end. Okay.
Using the side angle side method to prove triangles are congruent, the SAS side angle side postulate states that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. The included angle is the angle formed by the two sides. The following figure illustrates this method. Given triangle QZX is isosceles with base side QX. Side JQ is congruent to side XF. Angle 1 is congruent to angle 2. Prove triangle JZX is congruent to triangle FZQ. When overlapping triangles, model your understanding of a proof diagram. Try redrawing the diagram with the triangles separated. Doing so can give you a clearer idea of how the triangle's sides and angles relate to each other. Focusing on your new diagram may make it easier to figure out what you need to do to prove the triangles congruent. However, you still need to use the original diagram to understand some parts of the proof, so use the second diagram as a sort of aid to get a better handle on the original diagram. The above figure shows you what this proof diagram looks like with the triangles separated. Looking at the figure, you can easily see that the triangles are congruent. They are mirror images of each other. You can also see that, for example, side ZX corresponds to side ZQ and that angle X corresponds to angle Q. So using both diagrams, here's a possible game plan. Determine which congruent triangle postulate is likely to be the ticket for proving the triangles congruent. You know you have to prove the triangles congruent, and one of the givens is about angles, so SAS looks like a better candidate than SSS, side-to-side postulate, for the final reason of the proof. Look at the givens and think about what they tell you about the triangles. Triangle QZX is isosceles, so that tells you that side ZQ is congruent to side ZX. Look at these sides in both figures. Put tick marks on side ZQ and side ZX in the figure to show that you know that they're congruent. Now consider why they tell you the next given, side JQ is congruent to side XF. Well, if they were both 6 and side QX were 2, side JX and side QF would both be 8. So you have a second pair of congruent sides.
Statement 1. Angle QZX is isosceles with base segment QX. Reason given.
Statement number 2. Side ZX is congruent to side ZQ. Reason for statement 2. Definition of isosceles triangle. Statement number 3. Side JQ is congruent to side XF. Reason for statement 3. It is the given. Statement 4. Side JX is congruent to side FQ. Reason for statement 4. If a segment is added to two congruent segments, then the sums are congruent. Statement 5. Angle 1 is congruent to angle 2. Reason for statement 5. It is the given. Statement 6. Angle ZXJ is congruent to ZQF. Reason for statement 6. If two angles are supplementary to two other congruent angles, then they're congruent. Statement 7. Triangle JZX is congruent to triangle FZQ. Reason for the statement. SAS, using lines 2, 6, and